non-profit industry association. We drive development of Australia's bio-industries. And you may have seen a lot of us lately because we've been really intensifying our push and seeking to position the bioeconomy as a key opportunity in driving investment and job creation as part of the COVID-19 recovery. There's a lot of opportunity to expand now and really help Australia move beyond where we are right now. So for anyone who's interested in finding out more about what we do, potentially joining as a member, please feel free to contact myself or a member of our team. Today's webinar is Biowater, the significant opportunity for bioenergy in supporting decarbonisation and enhanced energy production of Australia's water industry. So the webinar today is offered in partnership with the Water Services Association Australia, and we thank them for their support. The webinar today will be moderated by Michael Froud of Water Capital. Michael has extensive experience driving global investment in projects much like those that will be shown today. So thank you so much, Michael. We will be answering questions. They'll be addressed at the end of the webinar. So if you do have a question, type it at any stage into the chat bar at the right of the control panel, and they'll be addressed at the end of the webinar. Before we begin, can I just ask that everyone turns off their camera and their microphone just to minimise any distraction and distortion for the speakers. And with that, Michael, I will hand you over the floor, or in this case, the screen. Thank you so much.
Thank you, Georgina. You're going to stop presenting there, are you? So I can just get into present. Great, thank you. That is that. And okay. Good afternoon, ladies and gentlemen, and welcome to the latest in the series of webinars presented by Bioenergy Australia. In this webinar, we are exploring the maximisation of resource recovery through the leveraging the synergies between waste and wastewater management. We can unlock the organic feedstocks available in waste for co-digestion. We have a wonderful group of presenters for you today. I won't go through all the details you've seen on the screen, but Dan Lambert, Water Lead at ARUP for Australasia, Sean Cummings, General Manager, Infrastructure Technology at Barwon Water, Kunal Shah, Managing Director for Asia Pac in Energia, Ash Naylor, Project Manager for Yarra Valley, Travis McNeil, General Manager and a Power Gen Specialist at Evo, and John Q. McEllis, CEO of Hydrolux EPCO, presenting on sludge to energy. Ladies and gentlemen, this is an interesting and very packed presentation that we have here. Sorry, I'm just going to do that here. And so without further ado, I'd like us to get going. So Dan, if I can pass this over to you, and we will get moving. Daniel, have you got it?
Mute. There we go. Can everyone see my slide? Just a sec.
Yes, we can see your slide. We just can't. There we are. That's better.
Fantastic. All right. So I'm excited to be speaking first today, and I've decided to call the topic, well, we've decided to call it the topic for the first presentation, the harvest, why bioenergy is ripe for the picking. And interestingly, I noticed a fantastic typo in the first slide, which said why bioenergy is rich for the picking. And so perhaps there's money to be made, and it's a really interesting topic. And I think you'll hear from some of the speakers today that there's a lot of fantastic work happening around the globe in the bioenergy space. If we look at globally, the renewables market and the Clean Energy Finance Corporation statistics, we can see that bioenergy only contributes 0.9% electrical output in Australia, compared to an OECD average of 2.4%. And there's a lot of opportunity to grow this market in Australia. And there's a few things I'll share today that are about things that have been inhibiting that, or that things that can be shifted to try and unlock this market more. But we also it's interesting to note that the size and scale of bioenergy plants typically has been smaller in the Australian market, and there are some bigger ones coming up, which is quite exciting. If we look at the bioenergy and energy from waste and compare it to solar PV, for example, we can see that solar's been on this amazing upward trajectory since 2009 type timeframe, and whereas bioenergy has been just a very slow growing market in Australia, and there's a lot of opportunity for us to step into this untapped renewable. Globally, we're seeing a lot of work, a lot of growth around the market. And in 2017, for example, bioenergy accounted for 70% of the renewable energy consumption overseas. And when we look at these countries and the size of bioenergy that's being produced for electricity, it's significant. And not only that, but I wanted to touch on the fact that that electricity, that bioenergy is also being used for biomethane that's getting injected into the gas networks. And across Europe, there's over 1,000 operational plants that are operating in that way. I was going to touch a bit on the Italian market, but I'm sure our friend Kunal, who's speaking a bit later, will talk about some more examples from Energia and work that's happening there. But there's a lot of lessons that we can learn from what's happening overseas, and there's a mature market, mature technologies, and we can really tap into that to accelerate the growth of this market in Australia. The second area globally I wanted to touch on was California, and there's a significant market being unlocked there, and there's a number of initiatives that have been used to help unlock that. And they're both really, when we look at California, they're both federal and state incentives under two separate programs. The first of those being the Renewable Fuel Standard, which fundamentally requires specific volumetric renewable fuel goals for the US. And secondly, the Low Carbon Fuel Standard, so the LCFS. And so in California, they intend to reduce greenhouse gas impact of transportation fuels. If you look at the size of the market and what's happening with bioenergy globally, really there's 11 million people employed in the renewable energy industry, and bioenergy is the second largest employer of people globally. So globally, we're seeing bioenergy really take off, and I believe we're on the precipice of seeing that happen in the Australian market as well. In Australia, there's an estimated, you can see that there's a huge estimated potential for biogas, so roughly equivalent to Germany's current production, and Germany being one of the leaders in that space. There's a lot of different types of examples that we can learn from around the Australian market. Obviously, today we're focusing more on the water industry and the applications in the water space, but and you can see a couple of examples around Loganholme, Bolivar, for example. But fundamentally, that estimated opportunity is equivalent to almost 9% of Australia's total energy consumption. I touched on what's happening globally before around not just bioenergy, but the gas opportunity. And I wanted to highlight the fact that when we think about the water sector, there's the waste energy opportunity from our wastewater treatment plants. But I wanted to encourage all of us to continue to think holistically about cities and how do we bring together some of these opportunities. So in Sydney, for example, we have Sydney Water with significant number and significant scale of wastewater treatment plants. But then we've got Gemina with a gas network that's actively looking for players who can provide gas into their grid. And that gas, so this is a quote from Gemina, in fact, the Gemina gas network can act like a giant battery and bring renewable gas to more than 1.4 million customers for cooking, heating and hot water. So there's an opportunity for us as a water sector to collaborate with other utilities to capture this opportunity. And not only that, but when we think about waste, it's not just about waste from the wastewater treatment plants, but there is a huge food waste problem in Australia, which is estimated to cost the Australian economy about 20 billion a year. You can see some stats there around the volumes, but fundamentally 7.3 million tonnes of food wasted every year. Now imagine we worked as a water industry with the waste sector, with the electricity and gas sector to look at how do we bring together more of a circular economy approach thinking to what we're doing. Now, I'll touch on that a little bit later, but not only are we seeing this convergence of water, energy and waste, but we're also seeing an increased appetite from investors around the market. And you can see many of the people who've dialed into the call today are investors. It's not just what can we do as a water sector, but it's how can we partner. And there's been a real focus on responsible investment approaches, looking at social, environmental value and risk in terms of investments moving forward. And not only that, but the Australian investors aren't just looking at the Australian market, they're looking globally. And one of the examples that Kunal will touch on in California, Rialto, was a collaboration with FSI, an Australian investor. So they're looking overseas and they want to invest into the bioenergy space in Australia too. So current barriers, and some of this will be alluded to by our other presenters, so I won't harp on this for too long, but we're seeing the bioenergy roadmap unfold at the moment, and many of you will have contributed to that. But there's a number of barriers and a number of lessons learned that we can apply from what's happening in California, from what's happening in Europe, to actually try and change legislation and change regulation to complement changing in thinking that can happen in the water sector in terms of partnering. We've got lots of talks on different projects today, so I'm not going to focus on these too much. What I will say is there's been some really significant movement in bioenergy in the industrial space, and I include water in that thinking. So we've seen some fascinating work around capturing wastewater in lagoons and using that gas. But we still haven't really seen that the market take off in the municipal sector, and I think that's going to be the next frontier, which we see over the next 1 to 3 years. The size of the Australian water sector is significant, as you know. There's assets that we have that, particularly when we look at wastewater, that's where a lot of this opportunity is to partner and use our wastewater assets more effectively, but also partner with the gas networks, partner with the waste sector. So when we talk about that circular economy approach, we can think about bioenergy as energy positive wastewater treatment. And ARUP's been doing some really interesting work with the Ellen MacArthur Foundation. If you haven't had a chance to look at it, those reports are available publicly, so you can just go to their website. But around circular economy thinking and as part of that, we've been exploring how can water join that circular economy approach? How can we shift habits that we've had in terms of how we run our sector and how we operate in silos to an extent? In the past, we've looked at gas separately, we've looked at electricity separately, we've looked at water and waste separately, and how do we think more holistically and capture that opportunity by thinking about the overall impact and opportunity we can have in cities? When we look at that opportunity, there is a real synergy, and we've got the synergy of what we do with our water and wastewater management systems and circular economy initiatives. And I think that's what I wanted to highlight today as we go through these presentations, to just think about what's the role that we can play in responding to the environmental challenges that we face within Australia, and how can we be part of the solution. Thank you very much. I'll exit out.
Thank you, Dan. And Sean Cumming here from Bioenergy. I'll just share my presentation.
While you're doing that, Sean, I'll introduce you. So Sean's from Bioenergy, and it's great that he's speaking next because Bioenergy is doing some really innovative work in the water space and in the waste to energy space, and some of these examples are very applicable in terms of circular economy thinking.
Okay, let's just see. Okay, bear with me, just trying to get this to share. That come through for everyone? Excellent. Well, thanks, Dan. I guess what I'm presenting today is a good case study that really kind of highlights the synergies that you spoke about between the water industry and the circular economy. So I'll start off with a bit of background on Barn Water. So Barn Water's got a proud history of providing high quality, affordable and secure water, recycled water and wastewater services to a population of over 500 people in southwest Victoria. And about 2 years ago, we had a good hard look at ourselves and thought, well, what's our real why? Why do we exist as a regional water authority? And what we recognised is our region, like a number of regions across Australia, we're facing some significant challenges when it comes to climate change, population growth, technology changes, and our economy was transitioning from a manufacturing economy as well. And what we identified is that we could really leverage what we do to provide regional benefit and help address these five key, these five key challenges that our region was facing. And what we identified is if we could create step change in 5 key areas through leveraging what we do, we could really benefit our region. So it involved us becoming high performance and entrepreneurial, but setting ourselves some really big targets in the zero emissions and zero waste space, which are relevant to what we're talking about today. So we've set ourselves a target of being 100% renewable by 2025 and zero net emissions by 2030, and recycling all of our wastewater by 2030. And in doing so, we realise it's something that we can't do on our own, and we've really got to focus on strategic partnerships. And that's really led us on a journey that's developed a zero emissions portfolio, covering a whole range of different, technologies to get us to the zero emissions space. And it's also influenced how we do this portfolio as well. So about 30% of our renewable energy is coming from behind the meter investments. You can see a large solar facility there, 3 megawatt solar facility. We've built and are operating at our main wastewater treatment plant. We've got a number of other solar and battery facilities around our region. But there's only so much you can do behind your meter in that space. And so another 30% is coming from a large power purchasing agreement that we've signed up with a number of other water authorities in Victoria to get renewable energy from a solar facility in northern Victoria. And we retained the remaining 40% of our profile of where we're going to get this renewable energy from to do something in our region and to do something that really adds benefit to our region. And in doing so, we kind of really tapped into what are the challenges that that we're facing, our partner councils we're facing, and also our major industrial trade waste customers we're facing as well. And what we identified was 3 key themes that we were all facing. So the first one was around addressing climate change by reducing emissions. So the water industry is one of the largest emitters in the state government's profile in Victoria, and that's because water is heavy to move around and energy intensive to treat. Councils, 34% of the general waste bin that everyone puts out each week is food organics. And when that breaks down in landfills, that emits methane, which is 25 times more potent than carbon dioxide in terms of a greenhouse gas. In terms of our waste challenges, our population is increasing significantly in our region, and our waste is increasing at a rate greater than our population. Our landfills are filling, and also waste security was a big challenge for industry as well in terms of knowing long-term sustainable waste management solutions and also knowing the costs of those as well. Energy and waste costs are also a big challenge in terms of maintaining affordable water bills, maintaining affordable rates, and also we found impacting on the global competitiveness of industries in our region. Landfill costs will more than double over the next 3 years. And over the last 5 years, gas and electricity costs have doubled. So that's really kind of impacting on the ability to compete on a global scale. So through that, we identified that, this initiative called Renewable Organic Networks, which we affectionately call RONs. And really that's looking at converting organic waste into both renewable energy and soil conditioner, soil enhancer or soil fertiliser products. And so we really call it an organic recycling process. And when I'm explaining to people, I liken it to a giant homebrew kit where we take the organic waste, it bubbles away, we use the biogas to run a cogen and generate both electricity and hot water, but also the product that's left over is really a valuable recyclable organic material, and it aligns really strongly with the state's circular economy policy, being recycling Victoria as well. And so with that in mind, our first Renewable Organics Network is actually underway in Colac. And this is a partnership with Australian Land Company and Buller Dairy Foods. So if you've eaten lamb from Coles, you've eaten lamb from the Australian Land Company, and they supply lamb to over 69 countries around the world. And I'm sure a lot of us have had a Buller ice cream as well. And what we've done is kind of flipped our mindset on our head. We used to say to these customers, actually take out as much waste as you can and then send us the rest and we'll treat it. And what we've said is actually, no, we'll provide a full waste solution for you. And while we'll do that, we'll create both energy and soil enhancer products. So they send their high strength waste to the Colac Water Reclamation Plant, where we create biogas that actually takes our plant completely off the grid and puts electricity back into the grid. And also provides hot water back across the road to the Australian Land Company. So the Australian Land Company currently use gas to heat up water for washdowns and the likes. This essentially offsets their gas use. And it's a double loop, so that the other thing is the solids that are left over get integrated into our biosolids facility, which thermally stabilises the solids and produces pellets that are reused around Australia now, New South Wales, Victoria, South Australia, and even shipped across to Tasmania. And that's gone from a product that we used to have to store and try to find a home for, to a product now that we don't have any storages. It's supplied to farms year round. And I actually wanted to do a trial with it a month ago, and I had to kind of fight with the market to get the product to actually do a trial. So this facility is under construction now. The first set of cogen will be in place by the end of this year, and we'll take the plant off the grid, and the full facility will be completed by 2022, producing about 1,000 households worth of electricity and 350 households worth of gas, and reducing emissions by 6,300 tonnes a year. The other aspect is the jobs that are created. So for every tonne of waste that is recycled versus disposed to landfill, there's 3 extra jobs that are created. So jobs that are created in the actual processing of the waste, but jobs that are created by the industries in terms of their, the waste and energy security that allows them to invest in their future, and jobs that are created in agribusiness as well in terms of the benefits that the products provide to farms. So quite a significant benefit there. And like Dan was saying, there's kind of a number of barriers to overcome to get these initiatives in place, and we actually call this initiative our WD-40. So if anyone knows WD-40, the lubricant, it took 40 recipes to get it right, and it took 40 recipes to get this right, pretty much, to a point that it stacks up commercially without funding and provides benefits to all the participating partners. And there's probably 6 key factors that really we found have made a difference with this, and it really comes to those synergies with the water industry that Dan was talking about. So one is leveraging the investment that's normally made in wastewater infrastructure. 2 is actually leveraging the large behind the meter demand that comes with a wastewater plant, and therefore not losing a lot of costs through network charges. 3 is the location. You already have an existing waste treatment location. 4 is the diversity of waste sources. So not only do we have waste sources from industry, but we've got domestic flows that are coming 24/7, and also food organic sources. And 5 is that ability to create a new form of energy grid in terms of hot water. So the water industry is the regulated provider of water. There's nothing that says what temperature that water needs to be. And that really unlocked a lot of the complexities of, connecting into networks and all that sort of stuff. And then the 6th one is the relationships the water industry has. So examples of Buller and Australian Land Company, they've been our customers for over 80 years, and we've got a good trusted relationship with them as well. So they all sort of combine to make this opportunity come into play. And with that in place, we've now turned our minds to a regional-based initiative that's really partnering with the 6 councils that are within our region, being Wyndham, City of Geelong, Golden Plains, Surf Coast Shire and Colac Otway Shire, and looking at servicing a population of about 600,000 when you combine all those councils. And we've looked at the waste in our region. There's about 150,000 tonnes a year of organic waste that's generated in our region, and a large percentage of that goes to landfill, which is an awesome opportunity to really upcycle that and create benefit from that. So again, this facility is creating that double loop, like I mentioned before, with a strong focus on energy. But I think in this one, we're actually doing a lot of work looking at the soil enhancer, soil fertiliser opportunities, and how do we really kind of create a product that's differentiated as everyone moves towards a circular economy and really has an edge against just normal compost. So we're looking at some innovative, I guess, forms of that product, and also innovative sustainable additives to that product to create what I call the super juice for all the farmers in our region. So this is under development at the moment. We're going through a 3-phase development process. We've identified all the waste in our region. We've looked at over 20 different combinations of opportunities, and we're narrowing in now on a preferred opportunity. And with that, we'll do, really come to an idea of what the preferred, I guess, process is by the end of this month, and then move forward to, I guess, taking that to a business case by the end of December. And as we do that, I think there's a couple of things that are really, beneficial to everyone who's working in this space. One, we're doing a lot of work understanding what the gate fee market is doing. So there's a lot of different drivers in terms of gate fee markets going forward, and it's one of the key areas that all of our partners are looking for some sort of idea or certainty on to assess what value for money is in this space. So we're doing a fair bit of work in that space, and like I said, where do you put the digestate, and how do you really maximise the opportunity of the digestate? So doing a lot of work in that space as well. So thank you for the opportunity to share what we're up to, and I look forward to any questions at the end. And with that, I'll pass over to Kunal to have a chat. Thank you.
Thanks, Sean. Thanks, Sean. Excellent presentation. Just a second. Some housekeeping. Michael, you can see the slide. Okay, good afternoon, everybody. Thanks, Dan and Sean, for setting up the stage. Then from the consulting and the background of 5,000 feet view of the opportunity which lies in Australia. Sean, excellent work as a utility. You've already taken one step forward, and you're looking at making it a bit more bolder. Now comes from the solutions provider side of the thing, which I'm representing. So, and again, thanks to Bioenergy Australia, Water Services Association of Australia, and Michael, to invite us to share this nice presentation and sharing our thoughts on the thing. I am sitting in Singapore. Thanks, the world is still global, thanks to the video conferencing facilities. And sitting in Singapore, obviously, we are very keen on the Australian market as a company, and that's where the presentation starts. So the topic of our presentation is how to leverage the synergies which exists between the water and the waste sector, and how to unlock a very large quantity of organic waste which actually resides in the waste sector. And with that, I would like to start the presentation. I'm Managing Director for Asia for Energia. The name of the company means anaerobic energy. That's what the meaning of Energia is. So we as a company have a vision of a zero organic waste future. We don't call it a zero waste future for planet Earth, but our mission as a company is zero organic waste future. As a company, we deal into almost all kinds of organic waste, right? From wastewater biosolids, we call it food waste or FOBO in Australia, municipal solid waste, food processing waste from food processing industries, and agriculture waste. From a series of process solutions, we convert that either into green energy, renewable gas, recyclables, fertilizer of various grades, and clean water. Again, a disclaimer, as a company, At heart and at core, we are a technology process integrator, but we do develop, invest, and operate facilities across the world as well. Just a quick one, Canadian headquartered, based in Singapore, covering Asia Pac. Over the past 30 plus years, we built about 1,600 anaerobic digestion plants and about producing 394 megawatt of electricity power. Some examples of material recovery facilities. These are waste processing facilities. Over 1,600 digestion plants. Okay, a disclaimer here. This presentation is not a sales pitch. This is presenting a concept, what we as a company have learned, what we have observed over years in about 4 continents, and spending millions of dollars in R&D. And all the concepts we are presenting are proven. They are not lab scale, and not all the solutions fit all. They are tailor-made for each opportunity. So what is the current global approach to waste and wastewater management at cities and councils? So this is the current approach. Every city has a waste management department, and I can tell you from the limited exposure I have from this part of the world, and wastewater treatment plants. Now, certain countries, both these agencies are quite intertwined, but in many cases, and I'm sure you agree that both have kind of a China wall, Great Wall of China, between the departments. And what happens is that the waste from the transfer station goes to a landfill. The wastewater treatment plant treats the wastewater. In some cases, recycle it. In some cases, you generate power. We all know that if it is only from the parasitic power generation from the sludge, you would generate about 30, 40, 50%, depending on the situation and the quality of the wastewater. But in general, the wastewater treatment plant is a net energy importer in most of the cases. And the biosolids usually send to the same, actually, landfill, or in some countries, it is used as a digestate. So in this approach, if you see, the synergies between the waste infrastructure and the wastewater infrastructure are unexplored. And this is what I want to present to you, that there is an opportunity to maximize resource recovery by leveraging the synergies between these two sectors. And that's how we suggest, and that's how it's been done in various cities in the world. The same city has transfer stations, and the same city has wastewater treatment plants. I would like to bring your attention towards the point wherein there are 2 star marks. There is an enabling technology which helps to achieve this, but more than technology, it is also the concept building, and that's why the role of a developer and an investor plays a very critical role in developing these facilities. So what happens is that at an existing transfer station, with the help of a technology, which is Energia's OREX technology, you extract organics from mixed waste. Those organics, and in later slides you will see, are polished and sent to a sewage treatment plant, either existing or new, or a merchant facility, where it is co-digested with sewage sludge. Because of food waste and the BMPs, what we call the potential of generating power, the same wastewater treatment plant has an ability to be converted into a net energy exporter. Because of the high heat available, you can actually go towards an enhanced chance of converting the biosolids to either dry them or make biochar out of it. So the one piece of technology which is important here is the OREX. And as we all know, at an existing wastewater treatment plant, when the sludge is being digested, it's usually a low solids digestion. When food waste is brought in, the same digesters have to be converted or upgraded to a high solids digestion. So the second piece of technology is what we call the Omnivore, which is a high solids technology. Now, the benefit of this approach, in our view and in our experience from various parts of the world, is it's an optimized approach for organics diversion, nice decarbonization or GHG reduction, enhance revenues for the utility. It's readily deployable because the infrastructure exists, especially on the wastewater treatment plant, and it's an inexpensive approach. So now I delve into what are the key technologies for unlocking organics feedstock and enabling co-digestion. So have a look at this slide, and here we have tried to say that how do we connect the dots. Now, as Dan mentioned, and when Sean mentioned, I think there are some very interesting utilities in Australia, like Barwon Water, Yarra Valley Water, Sydney Water, and some utilities in Western Australia, which are some or the other form of co-digestion. But those co-digestion usually depend on cleaner organics, or organics from industrial and food processing industries, are generally liquid, which can be pumped into a digester. So the retrofitted digester are very limited. What we have observed that over a period of time, the competition for this feedstock increases. The reliability of this feedstock is up and down, and there is an opportunity to unlock a very perennial source of organics, and that is the organics from commercial waste or residential waste. Yes, guys, I mean, this is happening. We're running facilities where we extract organics from municipal solid waste at either an existing transfer station, extract the organics. The important point here is two pieces of processes, which is extraction and polishing. When you extract organics from MSW, you will still have plastics, glasses, and grit, which needs to be further polished in order to put it into an existing sewage treatment plant. So once this is done at an existing transfer station, the organic pulp, either at various levels of solid, is then sent to an existing wastewater treatment plant, or a new wastewater treatment plant, or a merchant facility, where it can be co-digested with a high solids anaerobic digestion facility, generating, as you say, more power or renewable natural gas. And of course, with addition of food waste, you will have higher ammonia concentration, and there's an opportunity to convert that into an ammonium fertilizer, and also biosolids, which can be further upgraded to biochar. So step one is to lock in organic feedstock with a process which can extract organic from MSW. The step two is to either transfer this organics to an existing sewage treatment plant, where you upgrade the existing digester with high solids digestion technology, or if it's a new digestion facility, you can build in this into a new digester, or in the case, you can set it up as a merchant facility where you invest and build this facility and sell power. So first piece of the puzzle was extracting organics, and this is a machine which we've developed, and now we have a dozen of plants working on this technology, and a half a dozen under construction, where we put this on an existing transfer station, or it could be co-located in a wastewater treatment plant if there is space and regulations allow to extract organics. This is, in a simple layman language, it's like a garlic press or a sugarcane press, where you actually apply a lot of pressure on a mixed waste, and the producible part of the organics extrudes out of the mixed waste, and that goes into an organic polishing system. So this is the first piece of the puzzle. The second is the high solids digestion. Most of the wastewater treatment plants have existing digesters which are low solids, because the sludge comes at a low solids content. When you bring in organics extracted from MSW or high solids food waste, you have to upgrade the existing digester, and thanks God there is a process which can actually upgrade an existing digester in the same concrete volume and enhance it by 2/3, and that is, we have a process which has been again established. It's called the Omnivore. Sorry, and it's called the Omnivore process, which converts the low solids digestion into a high solids digestion. Interesting part, why the utilities should look at it. I mean, the topic of the webinar is also that why should utilities be encouraged to look at this kind of a synergistic approach? And I've tried to lay down a couple of points on this approach. So I believe that there is a genuine approach. We saw a couple of utilities on this call. We see a couple of utilities in Australia which have an attitude towards building these kind of facilities. But what we have observed various places is that how to lock that feedstock in order to justify a capex investment. And I think reliability is a key word in COVID, post-COVID world, is that this is a way, this approach is a way to lock in feedstock which guarantees the availability and modest tipping fees. An interesting topic, not technological, but it's a bit behavioral. We believe that source segregation of waste, which is a prevalent practice we have seen, is not necessary. And if it is going to be separated separately at home, and it's going to be dumped into the same landfill, might as well not to separate it at home, because the cost of collection, preparation, transportation to a landfill is much higher than mixed waste. What we want to do here and what we've done is demonstrated that mixed waste can be collected at a cheaper cost and organics can be extracted from that. I think the third interesting point is with this process and this approach, you can leverage existing infrastructure of anaerobic digestion at a wastewater treatment plant. So it's a nice political word. I think it's better return for taxpayers because then the same infrastructure could be applied to do more things. I think this is an opportunity for utilities to enhance revenues. You are now no more a net energy importer, you're an exporter. And at the same time, there are OPEX savings by doing this because at the same treatment facility, you can manage these two facilities, co-located or even at a separate facility. I think resilience is a word we have come across a lot with utility leaders across the world when we work with. I think every utility would like to be more self-independent, at least in external factors. And one of the external factors which run a wastewater treatment plant is the power. By this approach, you actually make more power, and that makes you a resilient utility. And last but not the least, I think it is a better service to community overall, because even though the mandate for the utility is wastewater treatment, but imagine with this, you can actually also help the waste folks by diverting waste, organic waste from the landfill. I think here, Michael, if I may take quickly, I would like to present a quick video which explains to you a couple of case studies, and that will help you to understand a little bit more about that. Just a second. I hope you can see the screen.
Energia was founded in California with the idea of finding cost-effective solutions for organic waste. We have been combing the world, acquiring technologies, built nearly 2,000 plants around the world, and now we're ready to bring all this experience to bear on the California market.
At the base of our company is our mission to solve climate and soil fertility.
We need to quickly ramp up next-generation bioenergy facilities that are focused on converting organic waste to the highest and best use that it can be put to, which is energy, and then compost and biochar as the two byproducts. And it's really critical for our clean energy goals.
We are trying to divert all waste, but the most important is organic waste because it generates so much methane. We have tremendous greenhouse gas footprint from that.
Energia has technology called the Organics Extrusion Press that has the ability to process solid waste of any contamination level.
The first step in the Energia process is to shred the waste material. After shredding, the material goes to the OREX press. This unique machine applies pressure to the waste material. The liquid fraction of the waste is extracted in this process. The last step is to clean up the liquid fraction and remove small bits of contamination. Clean organic slurry is transported to our local wastewater treatment plants, where it's converted to energy through anaerobic digestion.
Converting organic waste to energy actually provides the lowest carbon transportation fuels of any kind. In fact, it can be many times lower carbon than an electric vehicle running 100% on renewable power.
It creates fertilizer that can be used to improve topsoil, which is also a desperate environmental need.
With the digester technology, we're able to take something that we used to have to ship off and turn into an asset by using it to generate electricity and then obviously avoid energy costs moving forward.
1,300 other cities have declared climate emergencies. The leadership, it isn't being shown at the federal level. It's critical to work around that by having cities provide the leadership.
So we need 100 or 200 more of these projects to meet the state's landfill waste diversion goals, and Energia is leading the way with that effort.
We're in an era now where looking at organics recycling is really exciting.
Our mission is to convert waste into useful resources, protect the environment, and to sustain life for generations to come.
To leave a cleaner world for my kids in the next generation.
You get to do something at the end of the day you can feel good about.
Everyone has to believe that climate change is real. It helps you focus on areas where you can individually contribute.
Come join us in deploying organics recycling solutions across the state of California.
Energia was founded in...
I will share my screen again, and we're actually coming to the end of most of the presentation. So I hope that was a nice small movie time. If you see that video had almost 5 different utilities from the state of California, which are looking at organics diversion and which are looking at GHG impact goals. And this is the reason. In fact, this study just came out as an independent study from the governor of California, the government office, where they have looked at maximizing co-digestion at wastewater treatment plants. They have done an analysis that this could actually reduce 2.4 million metric tons of CO2 equivalent of GHGs per year, create a nice, interesting renewable energy source, and achieve a net statewide benefit of up to $255 million US a year. This is an independent report, and I'm happy to share that. A report as an independent. It has case studies on how utilities are working on enhancing co-digestion, not only with easily available organics or liquid organics, but also organics from MSW. This is the facility where we are proud to have an Australian investor who's invested into this facility. This is North America's largest food waste anaerobic digestion and co-digestion facility. This is almost about 60 miles in the high desert next to Los Angeles. It's going to treat 700 tons of food waste extracted from MSW in a transfer station, hauled to this facility, and about 300 tons of dewatered biosolids, which is going to be converted to Class A biochar, and about 1 million MMBTU per year equivalent of biomethane, as you call renewable gas, which is going to be injected into the natural gas pipeline. And this facility is a merchant plant, developed, invested, built completely by us, and we have very interesting impacts on the GHG. This is a facility which you saw on the video. It's a plant which is we've built on an existing transfer station. You can see this is in San Francisco Bay Area. You can see the distance. This is the transfer station, and it's about 5.1 miles to this wastewater treatment plant. This facility is very interesting. This transfer station would not only send this organics to one sewage treatment plant, but to a couple of sewage treatment plants. This is in the Silicon Valley Clean Water. This facility is an example that how a utility, this is an EPC project, it's not an investment project, how a utility designed and thought about co-digestion from the beginning in the tender process. Earlier, they were going to import about 1 megawatt worth of electricity. With co-digestion, they are going to now export 3 megawatt of electricity to the grid. And of course, recycle wastewater. I would not do justice if I do not mention to everybody on the call about this interesting project in the country where I live, and I'm very proud of this. So we talked about the China wall between the agencies. I think Singapore is one of the world's leading countries in terms of managing waste and managing wastewater. We all know about the National Environment Agency and the Public Utilities Board. If you haven't heard about this facility, it will come out soon. I'm happy to Google it down, but this is going to be one of its kind, world's largest integrated waste management facility, where it's going to take different streams of waste and co-located waste management facility, which involves food waste pre-treatment, a material recovery facility, and a waste to energy incineration plant. So different types of waste, incinerable waste, household waste, and food waste goes to the what we call the integrated waste management part of the facility, which obviously the food waste extracts the organics. This organics goes to a co-located sewage treatment plant with anaerobic digestion, which is going to treat the wastewater from the city. And the biogas generated from this anaerobic digestion is going to be sent to the incinerator for producing more renewable power. The rejects of the food waste treatment facility goes to the same incinerator, and the sludge, which is the biosolids. And imagine Singapore is a very small country, so we don't have landfill space. And the idea is to kind of divert 100% waste from the landfill. So this sludge is going to be incinerated because there's no space. So we had an amazing opportunity to be part of this facility in a small way. Singapore does something very interesting that at such a large scale facility, they wanted to set up a pioneering large-scale demonstration plant. I don't call it a pilot plant because it's really a demonstration plant, but 40 tons capacity, 20 tons food waste, and 20 tons waste activated sludge. And this was set up in 2016 just to study how the co-digestion would work in order to be an input to this massive multi-billion-dollar facility. So this is an opportunity. Again, a lot of stuff has been written on this. I would like to summarize, Michael, if I may, that I think there is an interesting synergy which needs to be leveraged. I think it will take a lot of people on this call, investors, developers, technology providers, equipment providers, consultants, utilities, and waste companies to come all together and bring this synergy, which I think is really cost effective if you look at the whole picture, and readily deployable. And I think it's a nice return to the taxpayers' money. It's a golden opportunity for utilities to decarbonize and help divert organic waste from the landfill. And in my way, I call it be future ready. This is coming today or tomorrow. Some countries are following it. It is coming. And I think Australia has that leading front in many ways. For investors on the call, we all believe, and Michael knows this as an investor himself, that the GHG potential of co-digestion or a waste biogas plant is multiple times that of any other source of GHG reduction renewable energy project. So from the ESG impact perspective, this is a very interesting point. And last but not the least, I think wastewater plants, we really view this as organics resource recovery center. With that, Michael, I come to an end of my presentation. And I would like to introduce now the next presenter, which is Ash. Ash is project manager at Yarra Valley Water, who are doing some exciting stuff. Over to you, Ash.
Thanks, Colonel. That's interesting technology there on that machine. Michael, can you give me a thumbs up? My voice is coming through okay? Great. And I'll just start my presentation. Right. And again, Mike, is that screen coming through on its own? That's all right? Yep.
It's coming now, yep.
Thank you. So, yeah, I'll be presenting on the project that I'm managing with Yarra Valley Water. We are very excited to be embarking on our second waste-to-energy facility. This photo is with the 3D rendering over it is taken looking over the Yarra Valley. If you notice, that's the white houses in the background is the township of Coldstream, but this is at the rear of our sewage treatment plant in Lilydale. And just briefly about Yarra Valley Water, we service about 2 million customers, residential customers, and 55,000 business customers, and service an area of about 4,000 homes, 4,000 square kilometres rather. And we have 9 sewage treatment plants, 2 recycled water to Class A treatment plants, stormwater treatment plant. We have around 10,000 kilometres of sewer pipes and 10,000 of water pipes, and 1 waste-to-energy facility. And that area there, that's about 90 kilometres across, going from east to west. And this started, so I'll be taking you through how it all began and what we learned from our first one and what we're doing with our second waste-to-energy facility. So I think it was mentioned before that the wastewater and energy and water and wastewater industry, one of the highest energy users when we have a desire to keep our power costs down and our greenhouse gas reduction down or offset in order to keep a downward pressure on customers' bill. In around 2011 or 2012, we started investigating co-digestion at our sewage treatment plants, but we found that with our smaller sewage treatment plants, this was not particularly suitable because our treatment plants are dotted around either small towns often, and they have fairly small sewage flows, like around 4 or so megalitres. With the ones that have a suitable amount of land for a waste-to-energy facility. I found the business case was proved with less sewage and more organic waste, so we ended up landing on food waste digestion, proposed in the end. And we built Wastewater. in 2017, and we partnered with the company Aquatop Maxcon to deliver and operate Waller. The two generators there up about a megawatt in capacity, and we receive about 33,000 tonnes per year of greasy waste, paunch and vegetable and fruit and veg market waste from Melbourne's food markets nearby, along with food processing waste. And that's co-located and powers the sewage treatment plant next door, and that's completely treated, completely powers that plant, and the remaining about 75% or so, depending on what's going on at the sewage treatment plant, about 75% of the power is injected into the grid, unless there's a peak demand day in which we can run the treatment plant on generator, and we can get some more financial benefits from the peak power prices. Now, some of our learnings from that project was around the waste. Knowing what's available, understanding your waste market is critical to the success, especially with the right waste. Make sure that the right waste is available of the appropriate quality, and that the design of the digester is appropriate for the waste profile. And the other thing that we learnt there was a bit of a mindset change as well. That it's primarily a waste receival facility that produces power, rather than electricity generator. So because a lot of your energy, we found, effort goes into the waste management and receival, and waste is the biggest contributor with the gate fees that we receive. Yarra Valley Water receives the gate fee and then supplies it to the operator. And of course, then there's the balancing the revenue input as well. So we had what you receive impacts the operations, and biogas production and the health of the digesters. So you have to make sure that you balance that waste revenue and the operation of the facility. So we decided to expand on the success of this, and during the years, some of our drivers were also updated. The Victorian State Government had introduced a Climate Change Act to achieve zero emissions by 2050, and in 2019 they introduced the Circular Economy Policy, and that influences our targets, and by 2025 we're targeting 100% power production, and the waste to energy is a part of a suite of projects, including solar panels at some of our treatment plants and our office car park, along with the that Sean mentioned, the solar installation in country Victoria, and another future solar plant at one of our treatment plants, Lagoons. And so where we're going to do this, it's in Lilydale. There's a bit of logic to this map, so we're expanding the facility out to Lilydale. The Waller facility is in the north. The reason why we expanded, we chose Lilydale as a site was because we had the land available, and because there was a treatment plant on that land, and we could really benefit off the behind the meter savings, the network charges, and also putting it out there, it expands our catchment area for waste, and we won't be cannibalising the catchment area for waste on the Waller facility. So just zooming in there's some key statistics on the proposed facility. We're looking at doing a 1.5 times the size of the first one, up to 50,000 tonnes per year, and we'll be proposing a design, build, operate and maintain contract with our pre-selected panelists. It'll supply power to the co-located STP and be about 30% of Yarra Valley Water's total power needs. And when you add waste to energy 2 plus waste to energy 1, you get around 50% of Yarra Valley Water's power needs coming from waste to energy. The orange area, by the way, on the side is the area that Yarra Valley Water has owned and it's been a sewage treatment plant in one form or the other in the last few decades. Lilydale treatment plant is to the south there, and there's about 1.5 kilometres. We're allocating about 3 hectares to the future site. And we, rather than putting extra load to residential streets, we want to make sure that we're a good neighbour and have the access road going straight through to Maroondah Highway. Now, our challenges for the facility, there's the usual, there's the community ones that we have highlighted, but we're managing the odours and traffic and visual amenity through a strategic community engagement program, and also managing the team. There was a former composting facility, open windrows on the site, so there is some memory in the community about that, and we have to respond to that accordingly. The other challenge, though, is digestate, which you're aware is the regulations generally see digestate as a waste rather than a resource, and it's a new potential product in Australia, particularly for reuse in agriculture, and this is pretty close to a heavy horticulture area in the Yarra Valley where there's a lot of strawberries and fruit trees. So we would really like to make use of that, develop another revenue stream. And we did a research paper that was presented at Wastewater that I suggest you have a look at that. And we're also doing some work with the EPA at the moment where to do some trials with digestate, and also working with Sustainability Victoria and discussing with some other water authorities to see if we can encourage the development of a regulatory framework and therefore a digestate market. So our next steps, we're doing a public consultation now, and we hope everything going well. We're looking at doing construction in late 2021 and hopefully commissioning by mid to late 2023. So that concludes my presentation there today. Thanks very much. I'll pass it over to Travis McNeil.
Okay, thank you very much, Ash. Thanks for that great presentation. I'll just get my computer ready to go. Sorry, I just decided not to play. Do that. Sorry all. What have I done? Sorry, I'll just, I've got a bit of a technical issue here. There it was. Sorry about that. Okay, right. Can everybody see the screen there okay?
Yeah, we can.
Okay, fantastic. Okay, well, welcome. My name's Travis McNeil from Evo Energy Technologies. We are a solution provider for biogas solutions. So we focus mainly on the digester back. So we don't have any equipment for digestion, but we do take the biogas and are able to treat that gas and provide various outputs from that. But if we have a look at biogas and the usage of biogas in wastewater treatment plants, specifically here in Australia, I think if you look at most of the large wastewater treatment plants, traditionally they all have cogeneration. That's fairly common at the large city wastewater treatment plants. But certainly a lot of the smaller wastewater treatment plants out in the regional areas traditionally don't have a lot of methane capture at all. And some of the ones that do would have just simple flaring. So there's really no beneficial use of the gas other than to combust it. Traditionally, when you look at small wastewater treatment plant and biogas cogeneration, it's generally not considered feasible. But I think when you look at the German model, they take a different approach to this requirement. So all of the wastewater treatment plants in Germany are required to have power generation from biogas. There's minimal allowed flaring. So flaring is only allowed if you've got an emergency or a situation where your engines aren't working. And most of the very small wastewater treatment plants, they even have cogeneration down to 50 kilowatts. So, and traditionally, most of those wastewater treatment plants are all targeting a net zero energy achievement. If we have a look at the solutions that we're able to provide to the market, the main one that we're working with is 2G Cogeneration. It's a German company. So 2G Cogeneration is nearly 25 years old now. So it's a very, very large company. Got over 800 staff. It's a public company listed in Frankfurt on the stock exchange, and they are they're in the top 3 CHP suppliers in Germany. 2G focus on gaseous fuels, so we look at natural gas, biogas, landfill gas, and obviously sewage gas. 2G's engine range, 2G have an engine range from 75 to 450 kilowatt, which is their own engine. When we look at larger projects where we're looking at cogeneration, we would be packaging Jenbacher MWM or MTU engines into those solutions. And that's really a choice of what the client may request in terms of their desired engine and what they may have already there. The engines are class leaders in terms of efficiency and reliability. Most of the engines are all at sort of 42.5% electrical efficiency, which means a much higher output per cubic metre of biogas. The service intervals are over 2,000 hours between services, and as I mentioned, the reliability is a key factor in the equipment itself. 2G also have hydrogen-ready engines, so we have the capability to either install a biogas CHP now and upgrade to hydrogen later. So obviously, as the hydrogen production in Australia starts to become more feasible, and there's certainly a lot of projects and a lot of talk about this at the moment, we can actually switch those engines across to run on a combination of biogas and hydrogen. So the beauty of the hydrogen, obviously, is, again, it's a zero emission fuel, so much more attractive. The solutions that we can provide, there's a number of ways we can deliver the projects. One is indoor, they're all indoor installations in this case here. So the open frame, which is just a bare engine into a machine house. The sound capsule is another option. So again, that's usually an indoor installation, but sound attenuated. But the preferred solution for delivery of biogas cogeneration would be the containerized solution. So the containerized solutions, we can package anything from 50 kilowatts up to 2 megawatt into a container solution. 2G have a variety of different sound output containers, so 65 dBA 10 meters down to 45. So if you've got an installation in a location that has some nearby neighbours, we can obviously provide a solution to meet that requirement. The cogeneration solutions in containers are very much a turnkey, a plug and play, so they're very, very rapid deployment. We can actually get them installed and operational within probably a week, so much quicker than doing the machine house installation. With 2G's containerized solutions, they also have complete biogas treatment. So you can see, obviously, the gas drying and reheating, which is part of the package here. Generally speaking, biogas is very humid, so it's fully saturated with water. It has a lot of contaminants. So the drying and reheating package of the system here, which is this system here, will dry the biogas and provide a very low humidity so that it can be delivered to the carbon scrubbing system. So these are a couple of examples here of active carbon tanks installed. So basically the biogas will come through with hydrogen sulfide and siloxanes and other contaminants. The active carbon filtration is able to remove those contaminants so that the engine can operate without any undue maintenance or requirements in that regard. We also supply a more complete solution in terms of the equipment provided. So anything from gas delivery, biological desulfurization, flares, biogas storage, and other technologies, which I'll run into in a little bit in a second. Biological desulfurization is a solution for a lot of wastewater treatment plants, particularly if they have high organic matter, such as a red meat processor or an abattoir, often you'll find that the hydrogen sulfide in the biogas is extremely high, and that can generally lead to very, very high OPEX costs in terms of changing the activated carbon. So the biological desulfurization plants will remove the vast bulk of the H2S, and they're very, very low cost to run. So they only require a little bit of water, some fertilizer, and a minor electrical load. So you can see the installations that we've currently got in place here in Australia is one on the Kawana Wastewater Treatment Plant. We've got one at Tees Meats in their Narracourt facility, and one at Southern Meats in Goulburn. So all of those, and we've got an upcoming project in Queensland for a large site there. So all of those biological desulfurization units are actually removing H2S from about 3,000 ppm down to below 100 ppm, which means they're able to be run into the engine without any further treatment. I think this one is a really promising technology in terms of what it can do for biogas cogeneration. The Sattler biogas storage domes are able to time shift the energy production from any wastewater treatment plant or biogas plant. You'll see down the bottom there that a 2,000 cubic meters of storage is equivalent to 5.1 megawatt hours of electrical output from a cogeneration system. So the ability to store your gas and then generate when the power prices are higher is obviously a big advantage. So yeah, if you look at the German market, a lot of the biogas plants in Germany, whether they be on wastewater or otherwise, have traditionally been running as a continuous operation. So they might have a 1 megawatt engine running 24 hours a day. And traditionally that's been the way they would deliver their electricity into the national grid. Over time that has changed, and now a lot of those biogas plants are now looking at putting in more generations. They may go from 1 megawatt to 3 megawatts of power generation capacity, but they can deliver that into the grid in a much shorter period of time. So they can take advantage of power prices when they are higher. The other solution that we're able to provide to the market is biomethane plants from ETW. So there's obviously a lot of discussion about this technology and capability at the moment. It's fairly common for these plants to be up and running in Europe now. Obviously, there's nothing in Australia at this point, so we're certainly excited to be involved in the market as biomethane becomes more readily accepted, and hopefully some projects get delivered. So the ETW biomethane plants are a PSA technology, so they're able to provide a very, very high quality gas with a very, very low energy consumption. So obviously the inputs from that biomethane plant, we can take landfill gas, biogas, sewage gas, or waste gas from mines, etc. And the output from that plant could be delivered as RNG into the grid, or CNG for transport or trucks, LNG. And there's also the capability to offtake CO2 from those plants if that's able to be utilised close by.
Travis, this is Michael. Are you close to winding up? Because I'm conscious of time here. Sorry.
Yes, okay, certainly. Sorry. If we have a look at the projects that we've currently got that we've done, we were involved with Kawana at Wastewater, Kawana Unity Water here. So we supplied a lot of the equipment there. We didn't do the domes, but we did the engines, the biological gas treatment, active carbon, the flare, and the blowers. Mount Martha Wastewater Treatment Plant for Southeast Water, that's the engine actually on site. It was delivered in March of this year. Obviously, COVID has put a stop to us being able to finish that installation. So that's a 360 kilowatt engine being installed there in a super silent container. Here's some of the other projects that we've completed. So you'll see the list on the left there. Upcoming projects for us, we're actually supplying a 360 kilowatt cogeneration unit for Barwon Water's Colac project that Sean spoke about. 900 kilowatts of landfill gas generator at Latrobe. Southeast Water, we have two 550 kilowatt engines going in on the Bonio wastewater treatment plant. We've got another project there for Gold Coast Water at Coombabah wastewater treatment plant, which is 550 kilowatts. And a very large 4 megawatt biogas project up here in Queensland with gas treatment and biological scrubber. So that's pretty much it for me. I'd like to pass it on to John now, and he can talk to you about what technology they have. So thank you.
Thanks, Travis. John, just before you start, ladies and gentlemen, I'm going to allow us to run over by about 10 minutes because there's quite a few interesting questions that follow here, which I'd like to do with John. So after John's presented. So where you go, John.
Great, thanks very much. Okay, I'll just get this. Okay, is that up on the screen, Mike?
Yes, it is.
Okay, great. Well, thanks everyone. Thanks, Mike, Bioenergy Australia and WASA for allowing us to discuss the sludge to energy project. My name is John Kimmikellis. I'm with Hydroflux. We're an Australian-owned environmental company that works in the municipal industrial water space. We hold our own proprietary technologies, and we're the agent for Huber Technology, who are from Germany. We provide technology to sewage plants, we build wastewater plants, we build sewage plants, and we operate and maintain a number of biogas facilities. Sludge to energy, which is the focus of this presentation, is a joint venture between Huber and another German company called WTE. And their goal and their vision is to build and operate green energy factories. They're currently building a number of bioenergy facilities in Europe and the Middle East, and to date they've constructed some 10 or so projects over the last 10 years. A little bit about Australia and New Zealand. So biosolids, a lot of people in this room are sewage experts. It's here to stay, biosolids. It's a consequence of wastewater treatment. And as population grows and as we get more advanced in technology in treating sewage, we produce more of it. So it's not going away. And the biosolids I'm referring to in this presentation is essentially the cake, which is a mechanically dewatered product. As you're all aware, it's rich in organic material and contains nutrients such as nitrogen and phosphorus. To give you an idea, Australia and New Zealand produces approximately 2 million tonnes of this wet material per annum, and the majority of these biosolids are actually beneficially reused. The last decade has seen some fascinating change over in Europe, which has led to a bit of a shift in how people view biosolids and how it's being treated. In countries such as Germany, and in the Balkan area and Eastern Europe, there's been quite a lot of public concern with the agricultural use of biosolids due to pathogens and the like. Many water authorities around the world are building strategies to combat climate change. We heard from Sean before about Bioenergy's net zero carbon emissions and renewable energy goals. So that's driving a shift in thought on how to achieve that. There's a rising public endorsement, of course, of renewable energy. In some parts of the world, in particular in Germany, there's a drive to produce phosphorus-rich byproducts to secure their supply of fertilizer, given the fact that world phosphate reserves are quite limited. And I think many of the water authorities would agree that they would like to build some certainty into their costing models and provide some resilience against legislative change. Biosolids disposal is quite a significant part of a water authority's cost in terms of sewage treatment. Very quickly, biosolids treatment, there's quite a few processes there on the market, from composting through to various forms of thermal treatment, which includes co-incineration, mono-incineration, gasification, and pyrolysis. So specifically sludge to energy, this is actually a mono-incineration process that Huber and WTE have implemented in the European market. The mono-incineration refers to the fact that only biosolids from sewage treatment is used as the feedstock. And this enables the recovery of a phosphate-rich ash that can be beneficially reused. There are 5 major process elements to the sludge to energy process. The first is the biosolids receival area. We then have a drying facility, which is required to obviously remove water and increase the calorific value of the sludge to enable auto combustion to occur. We then have the fluid bed furnace where the combustion is realised, and associated with that is heat and power recovery via heat exchangers and steam turbines. And of course, there's a comprehensive air emissions treatment facility, which typically consists of a multi-stage dry flue gas cleaning process. The core of the process, which is the fluid bed furnace, is actually a specifically built technology by Sludge to Energy. It's not a commercially available one. They've actually developed it for this application. Just a quick overview of the flow sheet. So on the left, we have our biosolids receival area. Now in Europe, this accepts wet cake from centrifuges and the like, screw presses, as well as dried material from sites that have existing biosolids drying facilities. We then have a dryer, which is typically a dish dryer or a belt dryer, just depending on the load. And then we have the furnace itself, followed by either a hot water boiler or steam boiler, and that's dictated by the size. So up to 3 megawatt, you're looking at a hot water boiler, and sort of above that, up to 15 megawatt, you're looking at a steam boiler. We then have the associated flue gas cleaning, which is a multi-stage process with the emissions discharge. And down the bottom here, there are the two byproducts. And those byproducts are essentially less than 10% of the input. So we are talking about 90% reduction here of the volumes. And the bulk of that is actually the phosphate-rich ash. And then you have a small amount of residue, which is produced from the flue gas cleaning process. Straubing in the south of Germany is an operating reference. It's been going since 2007, 2008. Lots of experience gained from this site. And the project has proven to be self-sufficient with the energy that is recovered, driving the sludge to energy process with a 0.6 megawatt output, and that includes providing thermal energy to run the drying system. So, so based on the outcomes of this plant, the city of Straubing have just in July actually signed a contract with Sludge to Energy to provide a 120,000 tonne per annum facility, so quite a significant facility, with 14 megawatt output to manage biosolids from the entire city and surrounding areas. And the great thing about the proposed or the project under construction is not only will it run the sludge to energy plant, it will actually run the sewage plant, which means you'll have net energy neutral sewage treatment, and on top of that, it will actually provide electricity into the grid to power about 3,000 homes. So based on that site and other sites that the S2E have built, some of the outcomes are that, pardon me, some of the outcomes are that the process has proven to be self-sufficient with no, sorry about that, no reliance on external energy. Phosphate has been recovered from these processes and even enriched using newer processes that have been developed and beneficially reused. There's a consistent 90% reduction in biosolids volumes, and the advanced odour treatment systems have complied to the quite stringent air quality regulations. Great endorsement from the community, who have really come on board with the process, and that's driven by the fact that it's energy recovery, and this has enhanced the water utilities reputation, and sort of clients see them as leaders in the field of renewable energy. But in the main, it's proven. It's a mature product now, and it's met all of its regulatory compliance in those existing plants. A few more projects under construction. There's actually about 6 under construction on top of Straubing. Hanover in the north of Germany is 130,000 tonnes per annum, which equates to about sludge produced from about a population of 2 million people, close to 11 megawatt output. This plant will actually produce surplus energy to power up 5,000 homes, so quite significant. And this unit will be operational in 2023. On a smaller end of the scale, 9,000 tonne per annum, which is approximately 100 to 150,000 EP or thereabouts. In Lithuania, this plant will simply be providing energy to run itself and the drying process, and enables the local utility there to reduce its discharge and recover the phosphorus. So this is a system that's near complete, with commissioning starting early next year. So sludge to energy has been around for 10 years. It does assist water utilities in securing a long-term strategy in terms of disposal of biosolids. I believe it's something that the Australian and New Zealand water authorities could review to help them meet their sustainability targets. It does unlock the energy potential of biosolids, and it can provide energy neutral sewage treatment and also provide a surplus energy demand for domestic use. Performance has been well proven with 10 years of operating experience, and certainly a very high level of reliability and regulatory compliance. So that's my introduction into sludge to energy. So I'd like to thank everybody for allowing us to introduce this technology, and I'll now hand it back over to Mike, and I wish everyone a great afternoon.
Thank you, John. Okay, everybody, thank you. Thank you for your time. What an amazing set of presentations, guys. You did a superb job, so thank you very much indeed for that. There are a lot of questions. We have 3 minutes of our official time left, but I'm going to allow it to run a little bit. Dan, nice to see your dog in the background, by the way. Look, I just want to kick off with a first question, which I think it would be helpful to get our discussion moving here. So Kunal, question for you. So as one of the leading developers of food waste and mixed waste processing and digesting facilities, what do you think is techno-commercially more attractive in the Australian context? And how can Australian water utilities leverage from this?
Thanks, Michael. Good question. I think in countries where food waste is separately collected, there could be a food waste treatment facility. In many places, the waste collection is not happening separately. So extraction of organics from waste is interesting. Yesterday, I was on a presentation with the Victoria government, which talked about diverting organics from landfill. So I think every utility looks at 3 or 4 things to happen. One is to become more resilient. Second, to save OPEX. Third is to look at reducing the GHG impact of the utility. And number 4 is to serve the community better. In our humble view, I think unlocking feedstock, which is the largest amount of organic feedstock in the Australian context, lies in MSW, and utilizing that to bring it to a wastewater treatment plant would be more techno-commercially feasible and viable.
Thank you, Kunal. I'm just going to pick up some questions along here. Apologies if I miss yours. There are many. So David on here says, different countries have different regulations. Heavy metal is also a derivative of the nature of wastewater going into the wastewater treatment plant. Regulations generally would drive this, but fortunately a lot of case studies of action plants exist globally. Does anybody want to comment on that? Because I think it's a very relevant point here. Feel free, any speaker at all to come up. That'd be good.
I think we tried to reply a little bit. I think heavy metal concentration is also a factor of the quality of wastewater coming in. And is it industrial wastewater or mixed with municipal wastewater? Generally, what we have seen is that there is this concern of heavy metal concentration. Now, every country has a rule for digested disposal. UK has a different rule. California has a different rule. For example, in the UK, after pasteurization of the sludge, you can actually land apply it. Same goes for California, where after treatment, it becomes less septic. And the point here to be seen is we talk about heavy metals, but what is happening today? Today, it is all going to the landfill. So this is at least a step up to do a digestion, to produce something better, reduce the GHG, and then make the sludge less septic, pasteurize it, and convert it into something useful.
Thanks, Kunal. Sean Rainford's raised a question here as well. Perhaps I can just go on to that one. So sorry, Kunal, this is back to you again. Actually, do you experience any challenges in meeting soil amendment quality standards from contaminants, such as chloride or metals from the solid waste organic fraction?
I think, yes, I will be speaking with him, but I think chlorides in food waste, yes, more so in Southeast Asian and East Asian countries, which use a lot of soupy waste and a lot of salt. So all that salts end up in the organic pulp. However, that's the beauty. When you co-locate food waste plant and sewage sludge co-digestion plant together, you can actually, the filtrate which comes out after you've removed ammonia can go back to the wastewater treatment plant and gets diluted with the sewage coming in. So the overall effect, what we've seen, is not so bad. The chloride content coming in the incoming food waste.
Okay, thank you. Change tack here, and I'm going to leave that. I think we may have lost Sean. I think he had a bit of an emergency going on, so we were lucky to keep him for the majority of the call. Sean, if you're there, great, but I don't think you are. So the question was from Lauren, and she's saying, is there any suggestions on how to achieve confidence in the potential gate fees? We've found it quite difficult to get information on waste availability and price point. And can you recommend any specific approaches? So I think that's a very valid point. I'm not sure Lauren's coming from a financial investment perspective, but that is always a key issue on the gate fees on these projects. Sean, if you're not available, Ash, you may want to comment, or anybody else on here, Kunal, of course, but I'm conscious that you're answering the majority of the questions.
The commercial, it's Ash Naylor here. The commercial side of things, I'm not particularly familiar with. I know that we ended up hiring someone with a specialty in that, but I couldn't say much more than that. Sorry, the commercial side of things was outside of my expertise.
Okay, thanks, Ash. Kunal, do you have any comment on that, given the number of plants you've got?
Yeah, I think that's a good point. So on the point that how do we find out and map the waste available, I think it is location specific, county specific, council specific, and city specific. I think these days there is enough material available, for example, from the state of Queensland, New South Wales, Victoria. So that is one major example. The second example to map this waste is to look at and talking to the waste haulers, which are actually dealing with the waste. And the third thing is, which you raised a very important point, is about the tipping fees. So that's very interesting. Usually, these plants would not be financed by investors if they don't see a visibility of the quantity and the price of the feedstock. And that's one approach from one part from our side, is that as long as human beings are there, there will be organics in the MSW, which is food waste. And that gives a perennial source of organics. And the gate fees are usually linked because there are the same gate fees which are paid to the haulers to haul it currently, for example, to a landfill. So that would be the answer, Michael.
Yeah, okay, thanks. There's another question here, and this is the last question given we're running over, but do this and then I'll give an overall summary. So the question here is about biofertilizer and how does it compare with traditional fertilizers, which are much higher in nitrogen and phosphorus? Farmers are interested if there's a net benefit over traditional fertilizers. Anybody want to pick that up? Feel free to answer, Kunal, because you seem to be my go-to today.
No, I see there's a lot of interest in the entire participants on the digestate and the organic fertilizer. One of the reasons why Energia was started by the founder was the depleting soil sources. So as human beings are increasing, water is being recycled, desalination is happening and giving water. But what is not happening is the food which we grow on arable land is getting depleted day by day. And of course, thanks to urea and chemical fertilizers, it produces more, but it also has a toll on the land. I think in general, there is an increase in organic fertilizer, the market for it. And just go to a supermarket, organic vegetables are 2 times the price of normal fruits and vegetables. And that's a growing concern we've seen. And I think there is an uptick for organic fertilizer, but this market has to be developed patience is the name of the game in this market. I mean, chemical fertilizers have been there for hundreds of years. So organic fertilizers started a few years ago, professionally and technically, although many farmers and tribal people still use organic fertilizer. But on a large scale, to have a regulation, I think it is moving towards that direction.
Thank you, Kunal. Look, I think we're going to wrap it up here. If I've missed your question, I apologise. One thing we will do in conjunction with Bioenergy Australia is make sure that we get back to you on all of these questions. We'll try and divert them to the relevant speaker. But if you don't get the response you need, please don't hesitate to contact either myself or Georgina at Bioenergy Australia. I'd like to take this opportunity to thank our wonderful presenters. You've done a marvelous job, guys, and I think we clearly have a very exciting market opportunity ahead of us in the next 10 years in Australia on the bioenergy side, and in particular in the co-digestion. And I look forward to seeing many successful projects in Australia starting to catch up, at least with Europe, in terms of what's going on in this space. So with that, I thank you all for your time and wish you a good evening.